let's just move on further and talk about some of the mixed problems which are totally based on the relationship between the zeros and the coefficients of a quadratic as well as the cubic polynomial. So let's just start with the question number 1. It says find the zeros of the polynomials and verify the relationship between the zeros and the coefficients. So let's just see those polynomials as the very first part is x square minus 2x minus 8 and the second part is 4s square minus of 4 of s plus of 1. So let's just start the solution set of these particular polynomials. As first of all, we'll start with the very first part. In the very first part we have x square minus 2x minus of 8. So let's just find out the zeros using the splitting the middle term method. So x square minus of 2x minus of 8 can be expressible as we have to look out for the two numbers whose product is nothing but 8, and after subtracting them we will get the answer as nothing but is equal to 2. So 4 and 2, obviously we can express it as x square minus of 4 minus of 2 of x minus of 8. Further, this can be expressible as x square minus 4x plus 2x minus of 8. We can take the elements common as x minus 4 plus 2x minus of 4. Further, we have x minus of 4 and x plus 2. So this is nothing but the zeros, or this is nothing but the factorization of this particular quadratic polynomial, and further we can able to find out the zeros by substituting them is equal to 0. So at the end what we can see that 4 and minus 2 are the zeros. 4 and minus 2 are the zeros of the quadratic polynomial x square minus 2x minus of 8. As we can substitute, each and every term should be is equal to 0. So when we will substitute x minus 4 is equal to 0, we will get the answer as x is equal to 4, and when we will substitute x plus 2 is equal to 0, we will get the answer as minus of 2. So these are the two zeros. So let's just start with, let alpha is equal to 4, beta is equal to minus 2 be the two zeros. So let's just take alpha as 4 and beta is equal to minus 2 be the two zeros, of this particular quadratic polynomial. So again, we are verifying first of all sum of the roots or the sum of the zeros is equal to alpha plus beta. So alpha is 4, beta is minus 2. So 4 minus 2 is nothing but is equal to 2, and it can be expressible into the formation of minus b by a. How? Let us suppose we are taking a general quadratic equation ax square plus of bx plus of c. Now let's just compare it for the value of a, b and c. We can see the value of a is nothing but 1, b is nothing but minus of 2, and c is nothing but minus of 8 formation. So it means that we can write 2 as nothing but minus of 2 by 1, which is nothing but minus of b by a. As we can see over here, b is nothing but minus of 2 and a is nothing but 1. So hence at the end alpha plus beta is coming out to be equal to minus of b by a. The first relation is verified. Further the product of the zeros is nothing but alpha into beta. Alpha into beta means 4 into minus of 2, which is minus of 8, and we can express minus of 8 as nothing but minus of 8 by 1, which is equal to c by a, because the value of c is nothing but minus of 8. So hence this result is again verified. So at the end, hence the relation is verified. At the end, what we can say? We can say that the relation is nothing but verified for the two zeros 4 and minus 2. Now let's just talk about the second case. So let us suppose I am again writing it into the formation or into the journal form as ax square. As we know that over here the variable that is used in this particular part is s. So we can express it into the formation of as square minus of or plus of b of s plus of c. We can express it into the formation of the variable s. So after taking a comparison in between these two, what we can conclude that the value of a is 4, the value of b is minus of 4, and the value of c is 1. A is 4, b is minus 4, and c is nothing but 1. Now let's just find out the factors or the zeros of this. So first of all, 4s square minus of 4s plus of 1 can be expressed into the formation of 4s square minus of 2 plus 2s plus 1. Further, we can write it as 4s square minus 2s plus of 1. Further, we can write it as 2s minus of 1 minus 2s minus of 1, and hence at the end we can write it as 2s minus 1 into 2s minus of 1. It means 4s square minus 4s plus 1, the factors of it are nothing but 2s minus 1 into 2s minus of 1 type. Hence, after substituting each of them is equal to 0, we will get the answer as s is equal to half. Hence, half and half are the two zeros of 4s square minus 4s plus 1. As we can see that when we will substitute 4s minus 1 is equal to 0, we will get the answer as s is equal to half. Again, for this 2s minus 1 is equal to 0, we will get s is equal to half. It means both the zeros are similar to each other, means both of the values are same. So s as half and half are the two zeros. So let us suppose we are taking them as alpha and beta. So let alpha is a half and beta is a half be the two zeros. So let's just verify the relationship. Sum of the roots is equal to alpha plus beta, which is equal to half plus of half, which is nothing but when we will take the LCM, it should be nothing but is equal to 2 by 2. Hence, this is nothing but is equal to 1, and we can express 1 into the formation of minus of 1, and further we can write it as minus of 4 divided by 4. As 4 and 4 when get cancelled with each other, we will get minus of 1 again, which is equal to 1 again. And further we can express it into the formation of minus b by a, because the value of b is minus of 4 and a is nothing but 4. So we can express it into the formation of minus of b by a. Again, let's just talk about the product of the roots. The product of the roots is equal to alpha into beta, which is equal to half into half, which is equal to 1 by 4. And further, we can express it into the formation of c by a, because the value of c is nothing but 1 and the value of a is 4. So this is nothing but the relationship, or we can say hence the relation is verified. Hence the relation is verified that the sum of the roots is equal to minus b by a, and the product of the roots is coming out to be equal to c by a. So this is all about the question number 1. Now let's just move on further and we will talk about the third and the fourth part of the question number 1, in which we have to find the zeros and we have to verify the relationship of the zeros and the coefficient. So let's just talk about the third part. So let us suppose I am dividing the two sections. Okay, so let's just start with the third part. So we have 4u square plus of 8u. So we have 4u square plus of 8u. First of all, we can take the values common out of it as 4u, and the elements would be like u plus of 4u into of 2 is nothing but 8u. So we have 4u into u plus 2 is nothing but the factors of this particular quadratic polynomial. Again, we can find out the zeros by substituting them is equal to 0. So when we will substitute 4u is equal to 0, we will get the answer as u is equal to 0. And when we will substitute u plus 2 is equal to 0, we will get the answer as u is equal to minus of 2. So it means that the two zeros of 4u square plus 8u are 0 and minus 2. 0 and minus 2. These are the two zeros. Now let us suppose, let alpha is equal to 0 and beta is equal to minus 2 be the two zeros. Let us suppose we have taken alpha as 0 and beta as minus of 2, and further let us suppose I am taking it as, in general, I am writing it as AU square plus BU plus C. So by comparison, what we can say? We can say A is nothing but 4, B is nothing but 8, and C is nothing but 0, as there is no constant term, so C is 0. So sum of the roots is equal to alpha plus beta. The value of alpha is 0, beta is minus 2, so it is 0 minus 2, which is minus 2. We can express minus of 2 as nothing but minus of 8 by 8 by 4, as 4 into 2 is nothing but 8, and further we can write it into the formation of minus b by a. Why so? Because b is nothing but 8 and a is nothing but 4, so we can express it into the formation of minus b by a. So the first relation is totally verified. Let's just talk about the product of the roots. So product of the roots is nothing but alpha into beta, which is 0 into minus 2. Answer is nothing but 0, which is definitely is equal to 0 by 4, and we can express it into the formation of c by a, as the value of c is 0 and the value of a is nothing but 4. So hence again the relation is verified. So at the end, hence the relation is verified. We can say the relation is nothing but verified. Now let's just talk about the fourth part. In the fourth part, we have the quadratic polynomial as t square minus of 15. So let us suppose I am first of all writing it as at square plus bt plus of c. So by comparison, a is nothing but 1, b is nothing but 0, and c is nothing but minus of 15. Now let's just talk about finding out the zeros of this particular quadratic polynomial. So t square minus of 15 can be expressed as t square minus of root 15 whole square, because root 15 whole square is again 15, and we can use the algebraic identity over here. What is that algebraic identity? A square minus b square is nothing but is equal to a minus b into a plus b. So using this particular algebraic identity, we can write it as t plus root 15 and t minus of root 15. So at the end, these are the factors of this quadratic polynomial. When we will substitute, each of them is equal to 0. So root 15 and minus root 15 are the two zeros of t square minus of 15 quadratic polynomial. So let us suppose we are considering them as alpha and beta. So let alpha is root 15, beta is minus root 15 be the two zeros. Let us suppose these are the two zeros. So hence the sum of the roots, is nothing but is equal to alpha plus beta, which is root 15 minus of root 15, which is equal to 0, and we can express it into the formation of minus 0 by 1, which is nothing but minus b by a, as b is 0, a is 1, so we can express it into the formation of this. And further, the product of the roots is nothing but is equal to alpha into beta, which is root 15 into minus root 15, which is again is equal to minus of 15, and hence we can write it into the formation of c by a, because c is minus 15, a is nothing but 1. So hence at the end the relation is verified. Hence the relation is verified. So this is all about verifying the relationship of the coefficients as well as the zeros, and how we can find the zeros of the given quadratic polynomial.